great logistic customer from ourselves, dealing with IBM Cognos. I was a big fan of IBM Framework Manager. It's a meta modeling tool and providing a semantic layer to the customers, as well as Azure Analysis, for instance, but not persisting any data, just presenting a logical layer between data and the customers. Yeah, and last thing doing in my business life was reporting and dashboarding with several tools. I think all familiar more or less to you all. Okay, what we try to do with AnalyticsCreator, we set up a demo project where we would like to show our customers, without showing any customers' figures, what we do during the process of building a modern DVH, which deviates a little bit, sometimes drastically, from the historical ones we did on premise. And we'd like to show all functions to the customers. And one function was to create a database layer. And we'd like to do this by means of AnalyticsCreator, what we already did. And the outcome of all our project is in one or another form a semantic layer. And because there's a new function in AnalyticsCreator creating Power BI models, we would like to check this point and focus on this point, what is already done and what can be done to enrich this model and make it presentable to our customers. And therefore, I would like to show you our idea of a basic architecture of a modern DVH. It's all starting with sources. They are mainly structured currently, sometimes semi-structured, and in certain cases, maybe unstructured data. On the one hand, on the other hand, we have data that is incoming straightly, and we have to work those data instantly when they enter our system. This is maybe IoT devices or front worker devices, which has to be displayed on a dashboard or on a monitoring screen as well immediately after creating those data. So what we do, basically, as usually, we do data ingestion in some forms. Mainly, we're working in Azure, and therefore we mainly do this by means of data factory jobs, data factory ingestion pipelines. But I think at least 1/3 of our data ingestion happens via Databricks, because we suppose that Databricks is a quite good tool to deal with semi-structured data and providing them into a data lake. But this will be in detail in the next slide. Other thing of ingestion of the data is we have to capture those streaming events and dealing with it. On the one hand, we would like to store those data, maybe in aggregated form, but at least we have to store them to build later historical reports upon this data. And on the other hand, we have to report or analyze them immediately after creation of the data. And so we have two exit points from data streaming. One is persisting, though on the other hand, this is the real streaming data into Power BI. What do we do with data we already stored in the data lake? Yes, we do some data modeling on this data to make it more structured, more presentable to historical reporting, as usually we do in the past. And what I said before, we're always building a interface between the data, which is mainly a technical point of view, and the customer point of view of the data. Usually our job ends at preparing the data and presenting them to the customer. We don't really have lots of projects where we really create reports or analysis pages or dashboarding or something like that. We end up always presenting the data in a way that our customer can deal with those data on their own without our help. This is our aim in the project. And the last, maybe modern part of our architecture is the great topic of data science, where we do some data preparation training. but also movement of data. We also ingest data by means of such tools like Azure Synapse or Azure Databricks or something like that. We have a partnership with another company that we do instant machine learning, and this is also located in this square where we do all the machine learning and data science jobs. So this is our view of a modern data warehouse, and we think that we can provide all services to the modern and historical way of how we're dealing with data. So how does it look like if we regard a typical pipeline, and what about the surrounding services we used to see in this architecture? At first, there are some interfaces, and we would like to store this in some kind of a data storage, in a data lake. We divide this data lake up into at least 3 sections, where we can say we have some kind of section of raw data, some stage data where we provide some technical information about the data we get and structure them so that they can be queried in an appropriate way, and at least a curated data which can be a little bit compared to a data mart. Maybe sometimes it's really a data mart in a database, and sometimes it's just a structured area in our data lake. Next, we want to query the data in whatever the developer or data scientists are fit in, what query language they want to use. We do this as a serverless SQL instance, so that you can write T-SQL to query data stored in a data lake. We can use a dedicated push, which provide not only the T-SQL, the query language, but also a storage part. You can compare it to a SQL database at least. And the third one is a Spark pool, where you can use Python, R, C# or whatever you like to query the data, to deal with the data, to transform the data, whatever you like. This is accomplished by ETLs or ELT pipelines, whatever you design for the project. It's always dependent on what you're doing. Yes, and data is moved along this line by means of Data Factory or Databricks or whatever means we would like to use in an Azure context. The last one concerning the technical point of view is the data presentation, where we use Azure Analysis Service on the one hand, and or Power BI models on the other hand. For the Power BI models, I have to say, we recommend to use it if you have a premium account in Power BI, because then you have a dedicated environment, dedicated hardware that you can use, and it can be really compared to a tabular model, not in total, but I think at 80% of what you try to do. Unfortunately, cubes as the multi-dimensional service is not yet supported by Azure as a platform as a service product. And I think that Microsoft will not do that, but it's a personal opinion, because I'm dealing with Azure now 4 or 5 years, and I never heard an announcement that they try to put the multi-dimensional cubes to Azure. But you can use it if you have an infrastructure as a service environment in Azure. That's no problem. Yeah, and the last point is pipeline is the data analysis, and then we can see the whole structure of what we should do in our project to get data from various interfaces to present them to the customer. But the project does not stop at this point. We're expecting more and more data. I think that your project will increase the data amounts as well. And the more data we get, the more sources we pull in, the more data storage we use. The need for data intelligence is more and more pressing, I think. Data intelligence consists of data catalogs, where in 1,000 amount of tables are our data, what attributes hold them, what is the meaning of the attribute, all the data governance and permission control that is inside the system has to be displayed in a particular tool, in a particular service, and we're providing this service by means of Azure, which This service will identify every artifact in this entire pipeline, document them into a data catalog. We can provide some data governance services and rules to this data, and at least in the end, we are able to create the permission control from this data and persist them into the data storage or into the data query objects we have in our pipelines. Yeah, and finally, requirements should be done in a project, and we manage this with DevOps and agile development so that we can map the requirements to certain sprints and deliver them to our customers in a 2 weeks or whatever you define period, so that customer can see the success in short terms. So why a semantic layer? Just a brief slide for that. What you see here is a typical, or maybe untypical, but it's a display of a diagram that you may encounter in some of the project. We have one or more, usually more fact tables in the middle of the model, and we have something like a hierarchical product, a hierarchy to the product stored in different dimensions. We have maybe a salesperson that is mapped to a customer, but it's mapped via a many-to-many relationship. We have a date dimension in this model, and we have a self-referencing organization dimension displaying a parent-child hierarchy. And this is what is technically in the database, but we cannot present this to the customer, and therefore we like to make the customer use this model and display it in maybe in Power BI reports, and like you see on the top, or maybe you're more the figure type of human being loving to play with this in pivot tables in Excel. And there has to be something between the data and the customer that is displaying not queries to the customer, but fields that he can drag and drop into those reports. And this is the semantic model. And as I said in the beginning, it's really important to build this semantic model to gain the acceptance of the user, so that he works with our database, with our project that we created. So we started in our project with a more or less typical sales database. We took the database, the sample database from Microsoft, and adopted it in that way that we created a beer brewing and selling company located in the West Germany. Yeah, we have customers. We have some geographical information about the customers. When we're talking about cities, we're talking about state, provinces, and countries applications. Usually, we try to denormalize this relation of the geographical information. We like to have a customer and a denormalized amount of attributes describing where he is located and the hierarchy above the city to create a drill down in the report later on. We have some let me show us some fact tables, and we're focusing on the order sales and order lines in our project. That's what we try to do. There are some typical information like customers picked by person and something like that, order date, expected delivery date, and some order lines with the stock items. That means the products. I think basically a very typical sales enterprise relationship model. Entity relationship model, sorry. What did we do in AnalyticsCreator? I don't want to focus on how you're working with AnalyticsCreator, because Dimitri did this yesterday, and he's pretty much better in that than I do. Just focus on one or two facts, maybe. What I said before is we try to denormalize the geographical information. We did this with the cities, countries, and the state province information, and put this together in a geographical information, and afterwards added this to the customer information in our model. which leads to a dimension that contains customer information as well as geographical information. And this is reference to our fact table, which is the order line table in this circumstance. Yeah, we attached also the dim calendar information so that we can put in some informations about how our figures will develop over the time. Later on, we will create some time intelligence based on our fact table, and therefore we need at least one calendar information. And yeah, we try to create the Power BI model by means of this underlying AnalyticsCreator model view. So if you deploy this model, you will more or less come to this view. In bigger models, it's really possible that you have lots of fact tables displaying the different informations and different circums about data. But not every Power BI report is usually dealing with all data that you have in your company. So the third step of a Power BI model is to look for what information is really needed by this report. What would we like to display? And the first step then is delete a table that is not really used in this part of the Power BI reporting of your company. Power BI models used to reside in memory as a columnar database, and therefore it's really important that you really delete everything that you don't need, because everything that you have inside the model and you don't need consumes memory, and memory is still a little bit expensive in some ways, and deals with performance as well. And so I recommend at first delete everything that you don't need. That is, on the one hand, the tables, on the other hand, some informations inside the tables. Every column you don't need, please don't use it in the model and remove it. On the other hand, there are some columns that you will need, for instance, a date ID or a sort attribute for month, which we will refer later on. And you can add this in Power BI as well. I know the date ID, and the date ID I created is also supported by AnalyticsCreator itself. It's just an example that you can create some columns in Power BI on yourself and deal with this custom columns in your further developing of the model. And yeah, the basic information from this slide is that you only use items that you really need, because you do decrease size, and by that you increase performance. I could talk half a day maybe about performance tuning of a tabular model, because it's very interesting about what type of columns you use, in what sort order you import the columns, and this has a deep impact on how the model is compressed and how the performance is increasing inside this. Just take it away from this slide. As long as you decrease the size, you usually increase the performance of models. Maybe just one excursus to the basic naming that we experience during our project. Usually you take the namings from your database, and sometimes some dimension maybe have some typing naming in the dimension name, such as dim product denom. This means it's a dimension of products and it's denormalized. But I think the customer does not need the information that this is a dimension, because the displaying options of Power BI, Excel, or whatever you like, Tabular, Cognos, show that this is a dimension. Next, please delete all information that is of technical importance. No customer's interest is whether this is a denormalized organization or not. They just want to have the attributes and deal with the attributes in their reports. I would also suggest that you delete the fact term before the fact table, but it's not really necessary, because if there's a proper design fact table, there are only links to foreign keys, attributes of foreign keys, and attributes of countable figures, just such as gross sales, quantity, net sales, and something like that. And therefore, I recommend to entirely hide the fact table from the model. You can say, well, if you hide the fact tables, where do we find our measures? That's the next one. I recommend to create a separate a KPI table that contains all measures. It's easier to find for the customer in one, let's say some kind of a measure group, maybe from a cube, to find the KPIs on one point and not to search through all the fact tables that is in the entire model. That is the basic naming hints that I experienced is best practice in the projects and in the acceptance of the users. So, add an active reference. We often in the past we have more than one date information in a fact table, and what we often did is we created two calendar tables in the target model to reference one calendar as an order date and one calendar as an maybe accepted or something like the delivery date calendar, and we're filtering the report by means of the one or the other. That's one approach to do that. It's always a little bit difficult here how to correctly name the calendar tables, because if there are more than one fact in the model, it's not always the order date, which is the default link to this dimension table, but maybe some other ship date or whatever you like. And what are we doing? Yes, it's approach we usually do. And the next alternate approach is to create a second link to the same date table. I will switch briefly to a Power BI model where I can show you how it looks like in a model. You can see this is, maybe I make it a little bit bigger. This is the order lines table, and the straight line is the default connection from order date to the date ID in the date table. And this spotted line you can see here is the second, the alternate one. Why is it spotted? Because as you can see in this screen, this relationship is not really active. It's available, but you cannot use it by default. You have to do something in your KPIs calculation to use this this relationship. We'll show on the next slide how to do this and how to use this relationship. But it's important that this relationship is available, because without that we cannot calculate the KPI that we will refer on the next slide. You see, this is a different representation of the relationship, and let's see how this is used. What we can see here is a standard measure we defined in AnalyticsCreator and the representation in the Power BI model. That's basically this one. But what if we want to calculate a quantity based on the delivery date? You remember we don't have two calendar tables in this model, we just have one. And so we slightly adopt the calculation in this point. You see, it's a simple aggregation of sum for the order lines quantity. And as you can see here, it still is. We put a calculate function around this simple aggregation to tell the system we have to do something else to calculate this in a correct way. we have to use the function use relationship. And as a parameter, we have to parse the expected delivery date and the primary key of the date table to accomplish this particular calculation. Some of you can say, yes, okay, if you are building up this relationship in the formula, why do you have to put it in the model as we did in the slide before? It's a good question. And sometimes it's really difficult to explain, but it's the way Power BI deals with this data. At least we can do this, and maybe can show 2 KPIs in one report side by side, dealing with different dates and different relationships. It's up to you and your project to decide whether it's a good approach, or the one with the 2 or more calendar tables is more appropriate to your project. The data mention. Data mention is a very central point in Power BI and Tabular model if you like to deal with something that we call time intelligence. Time intelligence is some functions like same period last year. Suppose you're reporting up to the 15th of October, and you would like to compare the October this year to the last one. Yes, you can do it in SQL, but it's always a little bit difficult because you just have to evaluate dates until the 15th of the October, and you have to assure that the 15th of October of last year is the same date you refer to. With the time intelligence function, it's a lot easier to create those time intelligence. At first step you have to take is to mark the date as the date table. The system needs to know which is our calendar table, and this calendar table has to have no gaps in the dates that are built up in this table. And if you try it on the standard table we imported from AnalyticsCreator, you will get a hint that this date table cannot be marked as a date table due to some gaps in the date. And you might consider, well, what gaps in the date? There's always starting from the 1st of January to the last of December, and obviously there are no gaps. But if we have a look into our database, you will see that there is a year of 1900 in our database, and this is due to the fact that we created a default date that can be referenced by dates that are not really filled in this context. And what do we have to do? We have to create a filter at the step of importing the data. And in my sample project, I just created a filter that said, please don't use any data that is before 2016. And I just implemented as an is-after filter and as a date that shows the last of December of 2015. And after that, I can mark this table as a date table without any complications. Validation is successfully, and so our calendar table is marked as a date table in this Power BI context. And so what do we do with this information? We're applying time intelligence to some basic KPIs we already developed in our system. The quantity you saw in a few slides ago is still the same, sum order lines quantity. And now we want to use a time intelligence function to display the same period of the last year of the same KPI. And for that, we just need to apply a function that, again, calls itself calculate. We calculate the KPI that we already aggregated in the first step, and tell the system to refer this KPI to the same period of the last year. And now we have to reference a base date table that same periods last year can use to calculate the same period of the last year due to this KPI that we try to calculate. And that's all we have to do to calculate the same period of the last year. And now no matter which filter we apply to our report, it will always be the same period in the last year that we will show in the report. And this is not the only function that we can use to time intelligence. We can pull in some same period last month, same period last quarter, same period 4 months ago, same period 2 weeks ago, or something like that. And if we have both KPIs, the value of the current year, the value of the previous year, we can easily calculate delta between those years to show whether we're better or, no, let's not hope so, better than the last year. That's usually done by comparing year values to each other. As we talk about KPIs, I just like to refer to some properties of those KPIs that I think that are really, really important. At first, the description of the KPI. If you provide a model to a customer that is not really familiar with the data lying beneath this model, you have to describe, at least in the KPIs, I guess, what this KPI is about. What does this KPI do? And maybe how this KPI is calculated. It's up to you what you write to those description of a KPI and what you try to say to the customer, but you have to explain what is inside. Not every KPI is as easy as a quantity from order. It's sometimes more complicated, and sometimes there are similar names to entirely different definition of KPIs. And so you have to tell the customer, the user of your reports, what this KPI is about. Whatever you write in this description field will be displayed in Power BI if you hover your mouse over this KPI. There will be a tooltip in displaying the description of this KPI so that user can easily access the description and define whether this is the correct one to report in this report or not. If you're using the Q&A option of Power BI, I strongly recommend to use the synonyms field, because this synonym field is queried by the Q&A section of Power BI and can easily lead the customer to the correct problem he like to solve in this topic, in this report. Another one I would like to show you is the option of a display folder. Underneath that KPI table we generated, you can easily display those folders to group those KPIs. For this example, I did this with current values and last values, and I created a last year values folder so that all KPIs that are dealing with last year's values can be grouped in this folder. Maybe I can show you this to you briefly in this Power BI report. You see this folder on the top, and you can see the last year's folder. Maybe I make it a little bit bigger. You can see that the same period last year values are all grouped in this last year values folder. And if you are hovering the mouse, where is it? Yes. If you hovering the mouse about this over this KPI, you see that the description we just entered in our description field is displayed here in the tooltip of the KPI, so that you can directly communicate to your customer and tell him what this KPI is about. Okay. Going to the next. Calculated column is something you can easily do in AnalyticsCreator. Dimitri showed it in this presentation yesterday, how to calculate a quantity by unit price. And you can do this in Power BI as well. So I don't want to focus intensively on this step. It's just a calculation you can use more or less from AnalyticsCreator. And based on this calculation, you can easily create some KPIs that you try to calculate. In this example, I did it again with the period last year function. Okay, hierarchies. Hierarchies are a very interesting thing because you can, as you can see in the screenshot, you can easily use them to drill down to the data. You just need the quantity of 2020. Maybe you want to divide it into January, February, especially in month figures or in day figures, whatever you like to do. You can do this by creating hierarchies, and you easily right click on the starting point, the top level of your hierarchy. In this case, it's the year, saying create hierarchy. You then get a list of columns you can put under as the next level to this hierarchy. In our example, I did it with a field called month display. This is the field you can see in the screenshot. I created a field that is January 2020 or February, so that it's readable to the customer. And at the lowest level, we implemented the date in a hierarchy. And you finally see, I created a hierarchy of year, month, and date. Maybe you use some other hierarchies, maybe year, quarter, month, and date. Maybe you use year, week, and date. It's dependent on what you need in your project. And you can even create more than one hierarchy. We often have project where customers said, okay, we want to see the values first by quarter, and then month, and then day. And there are other departments in our company that are working with weeks of calendar. And so we put in two hierarchies, drilling down via quarter and the other one via week. That's no problem. You can create as many as you like. Just a brief hint concerning month. Usually, if you don't do anything, the hierarchy fields or the fields in the entire model are sorted by themselves. That means month display is displayed by the characters April or just December, as you can see, but that's not what we desire to do. We would like them to be chronologically, as we know it, starting from January, February, and so on. And in the properties pane of the attributes, there is in the advanced sections there is a sort by column, and we created a month sort key column consisting of the 4-digit year and the 2-digit month, concatenating them together as a sort key. And if you apply this sort key field as a sort field to the display, you will see. Sorry, was a little bit too quick. You will see the month ordered in the manner that you can see on the screenshot on the top left corner of this slide. I recommend that you do build this sort key field maybe at the database level so that you can use it no matter what type of technique of reporting you are using. It's always a good choice, I think. As we heard yesterday, we need to use incremental refresh even on models like Power BI or analysis services, because in our project we usually deal with fact tables that are around 10, 50, 100 million records, and we had one in our logistic customer, sorry. That we moved records around a number of 1 billion every night, and it's not feasible to load every record every day. Therefore, we need a function to use incremental refresh on our model, and to implement this, you have to do 3 steps to create this functionality to the model. At first, you have to create some parameters, range start and range end, to provide a mean to the system, where the system can see, okay, we have start date, we have an end date, and we have to filter the given fact table by this means. You then choose the fact table you want to filter. It can be one or more, but at least it should be one, because if there's no filter, that you cannot apply the filters, and therefore you cannot implement the incremental refresh. You have to provide a real date field in this fact table, so that you can apply a date filter as shown in this screenshot. If you have done this, you can go to your fact table and configure the incremental refresh. And I think that's pretty cool what they did to do this incremental refresh. At first, yeah, it's shown which table should be filtered by this incremental refresh. Next, you can say how many time periods, in this case, I chose years, how many time periods should be stored in the model. Everything outside this time period, let's say it's a fact record that is 6 years ago, will be deleted from the model. And in the next step, you can define the refresh data that, or other, the records that should be refreshed within this certain period. Again, it can be years or months or weeks or days, whatever you like. You just have to provide the period or the number of periods you want to refresh. And additionally, the system can detect data changes. If there's no change in the data we have to load, then yeah, why should we reload the data? That doesn't make any sense. And if you configure this, you can just apply all. And if you deploy your model to the Power BI service portal and configure an automated refresh in this portal, always these parameter settings are regarded when refreshing the data. It is really, really saving lots of time. And the next topic is, and a really interesting topic is row-level security. Suppose that there are different users in your company that does not have permissions to see all data, but only the data for the sales groups or buying groups or customers that are assigned to them. Therefore, you need a basic information, security information, where you can see what is the user and which buying groups does this user allowed to see. In my case, maybe it's a festival catering, or in case of this test user, it's the sports catering. And we liked the model to decide for itself by giving information of the current user, which rows to display to that user and which rows to hide. And therefore, we have to create a basic security information. This is, in this example, an Excel table. Usually it's a table coming from a CRM system or somewhere else in the database, and connect this to the desired filter, the desired attribute in the database. Next step is you have to manage some roles and filter the security info, which is this table, due to this role. There's a function inside of Power BI that is called username, displaying the current username of the logged in user. And this is set to a filter in the user table in the security info. And by means of that, if this table is filtered, and this filter is due to the filter direction given to the customer, which again filters the next steps in the relationships inside our model. And with this little effort, we have guaranteed that every user is only presented the data that he is allowed to view. Okay, and finally, some topics I would recommend to you to consider when creating Power BI models. You just have to think about filter directions. As we saw in the previous slide, it's very important if you're talking about security and filtering tables and in what direction is data filtered. Performance tuning, as I said in the beginning, is again a huge complex thing if you're dealing with models that are really greater than 40 or 50 or whatever gigabytes when a Power BI model is compressed. Documentation is a real interesting topic, really getting more and more interesting because the data is increasing, the data silos are increasing, and nobody can confirm that everybody knows everything about the data. And we have to know it because we are doubling our effort to create double KPIs, double dimension, and something like that. As well as complex formulas. DAX is a powerful language, a really powerful language, not as complicated as MDX, but really powerful, and you can do lots of things by means of that. Aggregation table is another thing. If you have real large tables of facts that don't need to be loaded completely entirely into the model, but can be aggregated. We can deal with computed tables. And one thing as a final tip from my side concerning visualizations, I searched in the beginning very deeply, how can I structure my report? And the easiest way is create a PowerPoint slide and paint your sections on this slide, export this PowerPoint slide, and import this PNG or JPEG or whatever you created into your Power BI report as a background. And you can easily structure your report. You can easily build custom buttons where you try to navigate through the report, close filters or close this one. It's really easy to use this PowerPoint exported JPEG, and you can really easily create some sections on your report to make consuming of your report much easier. So it was a very fast one because this was just 45 minutes and I can talk about it days and days. I hope you got a brief impression of what can be done with those models and why you should do this with the model. Yeah, if there are any questions, please feel free to ask them now, or yeah, contact me by email or phone number as you like it. Thank you very much for the audience.
Vielen Dank, Peter. Das war echt spitze. Danke. Oh, in English. Thanks a lot. It was great. Yeah, maybe we wait for some questions. We have a little time, so we can ask the audience if there are some questions.
Then it was too easy, or everything is clear?
Everything is clear. It was so good that
I doubt that.
I understand it.
To be frankly.
So then we do a short break. It's just now 7 minutes to 15 past 10. Yeah, do your break, drink a coffee or something else, and we see us in 7-8 minutes. Yeah, I think we started 2-3 minutes later if you need the time. Yeah. Okay.